and welcome to this channel, our Tipster Hub. And today we are going to look at another dataset and try to make sense of it in the shortest time possible. So if we look at the dataset we're looking at today, so it's from US government Social Security website, and it's on popular baby names. In this case, we are going to download the national data, which we already have, and it's here in this folder called names. If we click on one of the folders, we see it's basically in text format, and we'd like to have all these names read into R, and then we can do some quick summaries. But if we look at, just scroll down, we see, scroll down. It's up to 2024, so meaning we can look at data to as recent as 2024. Interesting. So we can clear this and say today we are going to look at baby names in the USA. And as I said in earlier videos, the reason for this website is basically, the reason for this channel is basically look at how you can use available tools to basically analyze your data faster. So first step would be to read in the data. So read in the data, and of course we are going to use so we load some packages, in this case read R, and we notice that the files are text files and they don't basically indicate the year that this text file belongs to, but we'd like to basically read one file that contains all these data sets. Seems like a very challenging problem because we are basically looking at from the 1800s, right? From the 1880 to 2024. So what we do, we go to chat and ask chat, I need to read in a couple hundred text files into R and make sure that each of them has a new column that shows the year. In this case, the year is contained in the file name. For example, so let me show you an example. For example, yob1880.txt. Okay, so for example, yob1880.txt, like that. So what does it say? You can do this efficiently in R, following these steps. Read all the txt files in your directory, extract the year from each file name, add the year as a new column, combine all the individual data frames into one. Here is a complete example using tidyverse. Okay, so we copy this, then we paste here. So you're saying load tidyverse, define the folder where your text files are located. So my working directory is mission 002, but the files are in the names folder. So what I can do is put a dot and then say they are in the names folder, right? I hope that works. And then list all the files matching the pattern. txt full names true. So let's just try this to see if it works. So we just run this part. Reverse. Okay, and then if we check files, even this head files. Yeah, I'm not sure if that will work. Okay, if we remove this, and then we run this again. Yeah, I don't know what I'm doing, but let's see. Head files. Sorry. So this is a part of the process of coding in R. Sometimes it works, sometimes it does not work. Yeah, I think this will work. And then we create a function to read a file and add the year column. So we are saying function that is taking the argument file path. And then it's extracting from the file name as the name of the year, and then read the file, assuming the format is name with no header. Is it name sex count? Yeah, that's it. That's it. And then add the year column, return. So we run that. We read the file. So this is for one file. You specify the file name. It extracts the name of the year, and then you read the file, and then you add a new column, call it year, and then you return the data frame. And then we say we are reading all files and combine into a single data frame. And we're using the map DFR function. So map DFR function, what is that? This map returns data frames by row binding and column binding the outputs together. Okay, so if we run all this, yeah, you can see it's reading each file one by one, one by one, one by one, until we have everything, and then we are combining them into one data set. There we go. So if we view all data, basically it should give us the names from 1880 to 2024. Perfect. And it gives us frequency in terms of the number of people that actually use the name, which is excellent. That's exactly what we wanted. Right, now that we have so I just want to know which 10 names have been the most common in history, in this case from 1880 to 2024. Summarize the data like this. Okay. Right. So we group all entries, total the curves for each name, count them in descending order, take the total. Okay. If we paste this, so top names, take all the data set, group by name, summarize by getting the total number of times this name has appeared in the records. Then you arrange in descending order so that we can see the most common. So we can add a title here, most common names in history. And then we print top names. Interesting. So the most common names in history in the US between 1880 and 2024 are James, John, Robert, Michael, William, Mary, David, Joseph, Richard, and Charles. Interesting. What if we want to find out the most common female names? Because I notice like in this summary we have more male names than female names. So top names female, and we say we are grouping, so all data filter just to select, and we say the sex is female, so that female, and then we ran, so top names female. Okay, there's an error there, so we just add one more. Yep. So the most common female names are Mary, Elizabeth, Patricia, Jennifer, Linda, Barbara, Margaret, Susan, Dorothy, and Sarah. Let's find out something. So if we still do the most common female names, but we say in the last 10 years, right? So that will be from 2015 to 2024 inclusive, right? Yes. So we say so this is the beauty about R, you can just filter and do summaries as you go. So we say female but in the last 10 years, so we filter, and then we also filter year is greater than 2014, and then we run that. So looking at overall, Elizabeth, okay, sorry, there we go. Interesting. So in the last 10 years, the most common name is actually Olivia. So there are more female babies being born in the US and called Olivia, Emma, Sophia, Ava, Isabella, Isabella, Charlotte, Mia, Amelia, Evelyn, and Harper. So definitely here there's some room for analysis in terms of let's say the 1800s, 1900s, and the 2000s. I'm very sure there will be a difference. We could try that. So start with most common names in the 1800s as per record. Just playing this and see what happens. And this is basically anything before the 1900s. And we see, let's see that, we run that. We see that before the 1900, most common names were Mary, Anna, Margaret, Elizabeth, Emma, Helen, Florence. Okay. Yep, already seeing some changes here. Bertha. Okay. And if we look at most common names, in the 1900s, most common female names in the 1900s, so that means anything greater than 1899 and less than the year 2000, right? Yes, and then we say 1900. So we see in the 1900s, it's Mary, Patricia, Linda, Barbara, Jennifer, Elizabeth, Margaret, Susan, Dorothy, and Betty. But when we go to the 2000s, is basically anything after 1999. Yeah, anything after 1999. And that becomes, all right, it's Emma, Olivia, Isabella, Emily. So these kinds of names have been increasing in frequency in the 2000s. Emma, Olivia, Isabella, Emily. Interesting. And probably we'll just do a last one for male names in the 2000s. So this is male, this is male, and this is same male. So for boys in the 2000s, in the 2000s, Jacob is actually the most common name in the 2000s. Michael, Noah, William, Ethan, Matthew, Daniel, Joshua, Alexander. Okay. So we can say, okay, so some quick summaries. Most common names in 1800s, late 1800s, 1900s, and 2000s, and already see some interesting patterns. Any other interesting summaries that I could do? Which names are rising or falling in popularity? Okay, so let's see. Top 5 male names and how it's the top 5 male names and how their popularity changed over time. Okay, so top male names filter by male, group by name, summary, top 5, and then you pull, then you plot the trends. All right, let's do it. Interesting. So probably we can just add to make it. So I think, yeah. This is interesting because we see the names James, John, Michael, Robert, and William, not very common before 1920. There's a rise up to 1960, and then a sharp decline in the 2000s. So James, John, Michael, Robert, and William. And if we do the same for female, so top 5 female names. female. Top female names over time. Then we run this. We see, interesting. So blue is Mary. So Mary rose in popularity until 1930s. That's 1940. Yeah, till the 1930s, and then it went down and has steadily been declining. This is Jennifer. There was a peak in Jennifer's between 1980s, and then they have all been going down and down and down. Perfect. I think that tells you and shows you the trends that have been happening in these names over the past couple of years. And then we also see gender neutral names. Which names are becoming more gender neutral? Interesting. If we do this, so names that are becoming more gender neutral. If we run this, it's taking some time. Let's see. It's an interesting one. Show names gender neutral. Interesting. So I see some couple of yeah, they should not be there, but Darian, Azaria, Justice, Jaylin, Armani, Renee, Finley, and Shiloh. What's the code doing? So it's grouping by year, name, and sex, summarizing the totals, then converting to wider format. Mutate and get a total between those named female and those named male, and then the ratio P. It returns the maxima and minima of the values, okay, over the total. Okay. Yeah. And then which name stayed in the top 100 for the longest span of years? View the names. So Charles, Elizabeth, James, John, Joseph, Thomas, William, Robert, David, and Mary. So those are the names that remained in the top for the longest time or the longest span. Are naming choices becoming more diverse over time? Okay, that's the last one. So diversity over time. Check name diversity. when we run this, interesting. So it's going up with a peak somewhere between, so this 40 years, this 20 years, 2020, somewhere between 2000 and I don't know 4 to 2010. That is when we have the highest diversity in names, but then it's going down. I think people are going back to the older names. Otherwise, thank you so much for watching. We have had a quick preview over this data set. Looks like a very interesting data set and so much insights that can be drawn from it. Subscribe and bye-bye for now.